the MIIB Innovative Internal Combustion Engine. Hello everyone, I'm Francesco Branco, mechanical engineer, and I will talk about an innovative internal combustion engine that will make a strong contribution to the protection of the environment in terms of energy savings and emissions of pollutants. Globally, 40% of carbon dioxide CO2 emissions are attributable to the transport sector. Of this 40%, road transport is responsible for 80%. Meanwhile, the only way to reduce emissions is to burn less fossil fuel. How? By adopting the innovative technology of the MIIB engine, a new technology different from the traditional engine. It uses less fuel and produces polluted emissions close to zero. Let's find out what are the advantages introduced of the MIIB engine for environmental protection. Unburned. We perform a complete stoichiometric combustion at constant volume that equals to a 5% reduction in fuel consumption, which results in a reduction of CO2 released into the atmosphere. Carbon monoxide, CO, eliminated. No carbon monoxide, CO emission, which did not form due to the full stoichiometric combustion at constant volume. Nitrogen oxides, NOx. These are reduced by maintaining a sufficiently lower temperature in the combustion chamber. Particulate matter. It has not formed due to the complete combustion at constant volume. Efficiency. Lower fuel consumption equals lower environmental impact. Let's compare the traditional engine and the MIIB. Obviously, the comparison is made with equal displacement and piston stroke. To better highlight the differences, let's analyze the movements frame by frame. First phase, intake. The movements differ in speed of the strokes of the pistons. In the MIIB engine is less. We have less wear of piston rings and we have less oil consumption. Second phase, compression. Most interesting phase where one can appreciate the substantial differences between the two engines. The piston begins to rise, compressing the air-fuel mixture. When the compression phase is at 40 degrees of crank from top dead center, the spark is fired in advance. The advance is one of the carriers of pollution of the traditional engine. In fact, it is necessary to start the combustion earlier in relation to top dead center. Otherwise, the combustion does not complete. Not only, but this, in order to run out, must be continued in the expansion phase. In the traditional engine, unfortunately, the combustion takes place at variable volume. Let me explain. The combustion of the mixture in the traditional engine occurs while the piston moves, causing the volume of the combustion chamber to vary. Hence, variable volume combustion. It is understood that the continuous variation in volume alters the combustion parameters, making it irregular. Let's resume with our compression phase. Note that in the traditional engine, to reach top dead center, there is about 6 mm missing. In this residual volume, the combustion gases, which would like to expand, are instead compressed. The consequence? Increase in temperature. This increases the reaction speed, thus forming all those pollutants we would like to avoid. Look at the position of the piston in the MIIB engine. There is about 2 mm left to reach top dead center. It's advancing. Let's continue to compress at 20 degrees of crank from top dead center. The piston in the MIIB engine has almost reached top dead center. 15 hundredths of millimeter are missing, less than the thickness of a hair. in the MIIB engine, we have thus made a mechanical advance that is at 20 degrees of crank from top dead center. The piston has reached top dead center. We have reached the third phase, the combustion and expansion. This is the stage where all the goodness of the MIIB engine is revealed, the combustion at constant volume without advance. Let's examine it in detail. We left the MIIB in the compression phase and noticed that at 20 degrees of crank from top dead center, referring to the traditional engine, the compression is completed. We can at this instant trigger the spark without advance. Combustion begins and will be completed at constant volume because the piston remains stationary in the position for 40 degrees of crank. 20 degrees firstly in the compression and 20 degrees after in expansion. A long enough and sufficient time to complete the combustion without producing pollution. Let's move on with the expansion phase. At 340 degrees of crank, the piston in the MIIB engine is still stationary at top dead center. As I said, it remains stationary for a total of 40 degrees of crank. At 320 degrees of crank, the piston in the traditional engine uncovers a cold part of the cylinder by putting gases in contact with it. So they cool down, with the consequences we know. In the MIIB engine, the cold uncovered part is lower. I would like to point out that in the traditional engine, as a result of the compression previously sustained by the gases in combustion, these gases are at a higher temperature than the gases developed in the MIIB engine. Therefore, in the traditional engine, there is a higher production of nitrogen oxides, NOx, a higher oil consumption, and a lower overall efficiency. Of course, even the exhaust phase of combusted gases present peculiarity. The piston remains stationary at top dead center, as in the combustion phase, for 40 degrees of crank, giving more time to complete the evacuation of gases, reducing pressure losses in the exhaust pipes in favor of a better performance. We have seen how a complete stoichiometric combustion at constant volume is achieved in the MIIB engine by eliminating the advance. Let's look at this summary diagram. The trajectory of the center of the foot of the connecting rod is highlighted in color. The crank button is highlighted in black. Note the circular trajectory of the crank button, while the center of the foot of the connecting rod has an almost flat hypocycloidal shape at top dead center. We have entered the fifth phase of the process. The piston reaches the top dead center 20 degrees of the crank before what happens in the traditional engine, reminding there still for 40 degrees of the crank. Combustion in this way evolves complete at a constant volume. It is also noted that the stroke of the piston identified with the foot of the connecting rod is 25% less than the stroke of the crank button, 80 mm versus 60 mm. That is, to have the same displacement with a traditional engine, you need to increase the diameter of the piston by just 13.5%. The advantage is enormous if we consider that the lower friction due to the shorter stroke translates into greater efficiency and therefore lower fuel consumption. In short, less pollution. Here you can see the section of the pushing mechanism. Now we will analyze another aspect that makes the MIIB engine different from the traditional engine: the driving torque. At 340 degrees of the expanding crank, we note that in the traditional engine, the crank arm equals to 7.4 millimeters, while in the MIIB engine, it is 28.52 millimeters. Our MIIB engine has more arm, almost 4 times more. Let's continue with the expansion. Scrolling through the frames, we notice that the arm is getting bigger and bigger. Greater drive torque means fuel economy, reduction of greenhouse gases, greater protection for the environment. Here you see the animation of the crank and connecting rod system, the heart of the engine. Watch the piston stop while the connecting rod and the crank are moving. It's fantastic.